All right, guys, let's jump into 10.3, which is much shorter than 10.2. It's just continued. So we are going to talk about line graphs. Line graph typically shows trends in a variable over time. Time is marked on the horizontal axis because it's the independent variable, and then the other data points are on the y-axis. So here we see age and we see weight. This is an example of continuous data. That's simply because you don't skip over a pound, you pass through every pound. You can't just jump over weight, it's a continuous quantity. So the time is on the x-axis, is age in years, and then his weight in pounds is on the y-axis. It says abuse, discrete data. Let me talk about that. Discrete data just means it's just dot, 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 no connected line. So a discrete data would look more like a scatter plot with just the points and they're not connected together. Abuse of statistics. The statistics presented are the same exact information, but what do you notice? Although you're saying they look very different, right? This is why it's really important, especially like in this age social media, in my opinion, where you can see a graphic and then it can be shared over and over again, and you're like, do I even know what I just shared? This kind of looks more alarming, like this jump off here is huge, whereas this guy doesn't look that alarming, right? So a lot of it depends on how the data is presented. Notice here that scale on the y-axis is very different. This scale is counting by tens, this scale is counting by 50s. So when we are counting by 50s, that data doesn't look so bad. When we're counting by tens, you can see it's quite a drop off from 2007 to 2008. So just be aware that sometimes data can be manipulated kind of to present a certain belief. Sometimes a relationship between variables cannot be easily depicted by even a broken line. So a scatter plot is needed. So this right here is a scatter plot, and it says it's the number of hours studied in the quiz course. So it's not, you see kind of a correlation where it's like the more they studied, the higher grade they got, but I can't connect them because they're still kind of all over the place. That's called a scatter plot. And this is called a trend line. So it's like the best line of best fit that represents the data. A positive association means that it's increasing. Okay, so as X gets bigger, Y gets bigger. So this is called a positive association, whereas this would be called a negative association. So if you ski down and ski down the hill, that's a negative. Where you're climbing up the hill, that's positive. And this has no association. Probably you can see there's not really like, do I draw a line this way or do I draw a line that way? You can't draw a line. Multiple line graphs, here's several line graphs on the same graph. So you can see that the blue represents severely crowded and the red represents crowded. And so sometimes you can display it on the same graph, two different lines. So this is just talking about how you need to choose the right way to represent the data. And sometimes that's hard to decide between a pictograph or a dot graph or a stem and leaf plot or a histogram, bar graph, circle bar, percentage bar, line graph, scatter plot. There are many different ways to display the data, and sometimes it can be tricky knowing which way is best. But that's basically this one, just talking a little bit about line plots and scatter plots, and attempt to do section 7.3. And if you get stuck, please reach out to me. Have a good evening.